How successful are software projects today? To find out, you may want to ask your favorite AI agent. I asked Copilot to provide statistics on software project schedule, effort, and cost overruns compared to plans. The accuracy of these numbers may be questionable, but the overall message is not. Software project cost and schedule overruns abound. Measuring software size throughout the project lifecycle provides the insights you need to reduce risk and improve your software project success. Welcome back to Software Size Matters, Why Quantifying Software Size is Critical for Project Estimating, Tracking, and Performance Benchmarking, a video series that explores how you not only can, but should be using software size measures at every stage of the software project, program, and portfolio management. Hi, my name is Laura Zuper, Training and Support Manager for Quantitative Software Management, QSM. We have covered the benefits of quantifying software size and presented sizing metrics and methods that fit the work that you do. In this episode, we present examples of how to apply these concepts throughout the project lifecycle. Quantifying software size helps you during each of the three major project stages. Estimation, producing scope-based rough order of magnitude estimates to support feasibility assessments at the initiation and planning stages, and detailed estimates to support project commitments as the scope is better understood. Tracking, the status of in-process projects and forecasting estimates to complete based on actual software size completed. And closeout, capturing completed project data to expand and refine data analytics, provide a basis of estimation of future projects, and conduct performance benchmarking to support process improvement initiatives and establish competitive positions. Much of the material covered in previous Software Size Matters videos emphasized using software size metrics to estimate project scope because cost, effort, team size, quality, and productivity all increase non-linearly with software size. In Episode 4, Choosing a Sizing Method, we discussed the benefits of estimating software project scope using T-shirt sizing early in the lifecycle when the scope is not well defined. More accurate estimates are generated from scope-based T-shirt sizes than from effort or cost-based T-shirt sizes. Once the software requirements are understood, detailed size estimates can be calculated using one or more methods. In Episodes 4 and 5, we discussed the variety of software sizing methods and the associated function units you can use to fit the data you have available and the type of work you are doing. Links to all the episodes are provided in the description below if you missed them. Use multiple sizing methods to reduce uncertainty. You can compare the results from each method, select one, or average them. Using different gearing factors for small, average, and complex function units like reports or interfaces in this example, not only increases the accuracy of software size estimates, but also promotes stakeholder participation in the process. Subject matter experts can help select the best size bin for each component. It is essential to continue to use software size metrics to track the progress of ongoing software projects. Actual software size metrics are the best indicator of project status. You can see the rate at which work is being done and, in this example, the cumulative to date compared to your plan. Schedule, effort, and staffing metrics are helpful, but they only tell you the resources expended, not what work has been done. Many organizations employing agile methods use product backlog buildup or drawdown charts. This chart shows that the cumulative number of story points defined has been under plan for several sprints. This type of insight provides early warnings so corrective action and replanning can be done to either meet schedule and cost targets or renegotiate commitments. Tracking plan versus actuals for multiple size metrics will provide interesting and valuable insights. We estimated the planned number of source lines of code and features to be delivered for one of our projects. Some things we observed are: the code count was much higher than planned in the beginning months, while features were slightly under. This was because some architectural framework development needed to be done before features could be completed. Actual source line of code counts showed steady progress consistent with the plan in the later half of the project. All features were assumed to be average size and able to be completed at regular intervals. Notice the straight line buildup of the blue plan line. We didn't have information to assign features to size bins. The relative size and dependency among different features can mean you don't get to take credit for completing them at regular intervals. The source line of code count proved to be a more accurate predictor of project status for this project. The feature counts helped us improve our size estimates for the next release. The really great thing about tracking actual software size is that you can run curve-fit forecasts for size metrics to calculate the expected completion date. If you are also tracking planned versus actual effort, which most organizations do, you can compute your actual productivity. QSM's process productivity measures the overall project environment efficiency, not just development teams, making it a reliable basis for forecasts to completion. A good practice is to run what-if forecasts to account for scope creep or potential changes in other key indicators, like increasing staff or having to mitigate product quality issues. That way, you can see the impact and risks of alternative scenarios and update plans accordingly. Software projects don't always turn out exactly how we planned. Ideally, what we plan to do, what we think we are doing, and what we actually did would show a high degree of overlap. Most organizations want historical performance data, but haven't dedicated time or resources to this discipline. Here are a few reasons for collecting historical data. Promotes good record keeping and supports AI tools. Not only do we have bad memories, but often selective memory. We need reliable data about software project outcomes to train and use artificial intelligence. It's used to develop performance benchmarks. Some of our customers are software vendors who bid on proposals and need to show that they are the best in the industry, or they may be organizations evaluating vendor bids using performance benchmarks. It accounts for variations in cost and schedule performance. You can answer questions like, was productivity down because of staffing issues, for example? It supports statistically validated trends and analysis. QSM software project history trends are valuable, but the best practice is to produce custom trends from your data. It makes estimates defensible. When estimates are based on historical data, you can let the data speak and reduce the impact of emotions and business politics. And it's used to bound productivity assumptions. Productivity is slow to change. Productivities you measure for certain project types today will be relevant for some time. There are no silver bullets. Historical data helps you recognize patterns. This slide shows the monthly actual source line of code counts for two different QSM projects. The code count we get is cumulative because that's the easiest. You can use any size unit if you can't get code counts. We started computing the monthly production rate by calculating the difference in cumulative values as shown in this chart. We can identify values that seem out of whack with the normal production rate of each project. That's a signal to find out if we made a data manipulation error, the code counting script includes something new, or what the cause may be. Data validation checks are necessary. Note the wide variation in monthly coding rates. Context about the project is important. Variation may reflect any one of the following: staffing changes, multitasking or time slicing between projects, as an example if you look at the April numbers. Feature complexity, Partially finished work, meaning you may not be able to check it in until it's done. Where you are in the project lifecycle, for example, tailing off at the end of the project, or scope creep, last-minute additions. In episode 5 of this video series, we presented the concept of using gearing factors to convert function units to a common base size unit to support project comparisons and capture complexity in size estimates. You can compute gearing factors for the function units you use when you have source line of code counts. You say, Laura, that's really awesome, but there's no way I can get a code count. Okay, here's another approach that works. First, select a similar function unit for which you have data. Here, we assumed a gearing factor of 300 implementation units per user story based on work that we had done. Next, we multiplied the gearing factor times the number of stories completed, in this case 496, to calculate the base size unit in implementation units. Then we were able to use that number to compute an average gearing factor for epics, 3,543 implementation units per epic. Now, the epic and story data can be used to define the t-shirt sizes for ROM estimates for future projects. Different projects may have different gearing factors for the same software unit, depending upon the rigor, formality, and consistency of your process. This chart shows software requirement gearing factors for different releases of the same application. Versions 9.0 and 10.0 are very consistent. On average, each requirement resulted in a big change indicated by the high gearing factor and thus more work. It doesn't take long for you to recognize patterns in your work. To summarize, quantifying software size supports every stage of the software project lifecycle. During estimation, software size is the best predictor of schedule, effort, staffing, cost, and quality outcomes. During tracking of in-process projects, software size measures provide a true picture of project status and a realistic basis of forecasts. And for closeout, software size measures support predictive models and provides insights for understanding project dynamics, and it also guides process improvement initiatives. In this video, we looked at the benefits of quantifying software size throughout the project lifecycle. I hope you'll join me for our final video, Benchmarking and Estimation Validation. See you there. Don't forget to like and subscribe to see more content.